Hello and welcome to our robot picking demonstration video, in which a robot arm picks objects from a shelf. Here we see a shelf being filled with randomly placed objects. The robot is tasked with picking up the blue box. We use a robot arm from Universal Robots and an adaptive gripper which is able to grasp a range of differently shaped objects. A 3D camera is also mounted on the robot, allowing us to create a detailed 3D image of the environment from different angles. First, the robot needs to create a complete model of itself and its environment. On the right, we see the model of the robot arm, including the gripper and 3D camera. Next, we turn on the camera, which generates raw 3D data from which all other elements will be modeled. Next, a model of the shelf is matched with the 3D data to obtain the position and orientation of the shelf with respect to the robot. Based on this model, a region of interest is defined in which the robot will look for the desired object. All objects in the region of interest are segmented from the shelf, and the position and orientation are approximated by a bounding box. The dimensions of the bounding boxes are matched to a database to identify the object the robot has to grasp, which in this case is the blue box. For the selected object, the robot loads a set of pre-learned grasp positions and orientations that can be used as targets for the end effector of the robot, indicated here by the colored arrows. Not all targets are feasible. Some might simply be outside the reach of the robot, or the target could be infeasible due to obstructions of the shelf or other objects. Once a feasible target is selected, we use a motion planner to calculate a collision-free path from the current robot position to the target position. For the calculation of the path, the motion planner takes into account the models of the shelf, objects, and robot. When the robot reaches the target, it grasps the object using its adaptive gripper and then moves towards a predefined drop-off location and deposits the object. We now switch the objects on the shelf and repeat the exercise with the exact same software to show that the robot can pick up objects regardless of their position and orientation.